I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Number 10. Melting glaciers in polar regions. After existing for millennia, the northern section of the Larsen B ice shelf in Antarctica collapsed between January and March of 2002, disintegrating at an alarming rate that stunned scientists. It is estimated that melting is occurring at 9% per 10 years, which will only get worse with rising temperatures. This isn't just occurring here, though, as several colder climates, such as Greenland or Glacier National Park, is also losing their ice regions. The water melting starts out salt-free, causing it to remain near the surface, which in turn is slowing the northern advance of warmer water from the North Atlantic Current, a sort of ecological conveyor system. This leads to colder temperatures, higher sea levels, more storms, ecological destruction, amongst other detrimental effects on our planet.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Over the last few billion years, species have appeared and disappeared from our planet like guests at an open house party. Sometimes they've shown up in droves, making the party swell with new forms of life. And other times, the majority of the guests have headed for the exit virtually all at once. The first big swell came about 550 million years ago, when the earliest animals appeared and diversified into virtually all the basic body shapes we know today. 100 million years later, the warm, shallow seas were packed with tiny plants and animals, essentially hors d'oeuvres for a plethora of bigger creatures like trilobites, conodonts, brachiopods, and corals. But just a million years after that, 4 out of 5 of the world's marine species were gone. Only the rock record can tell us what happened to them. But most ancient rocks have been scattered, buried, or destroyed over time. The best clues we've uncovered so far come from northern Africa, which 450 million years ago was part of a supercontinent near the South Pole. Outcrops dating back to that time contain the track marks of an ice sheet's vast expansion, as well as piles of rocky debris left by its rapid melt. What's more, the mass extinction appears to have unfolded in 2 distinct pulses, one in sync with the ice sheet's growth and the other with its retreat. In other words, it appears that our planet's first major party killer was an ice age. And yet, this revelation has created more questions than it's answered. Much of the life in the shallows probably perished as the growing ice sheet locked up more and more of the world's water. But why did so many deep water organisms disappear along with them? And why did some species survive the ice age only to die as seas rose and temperatures warmed at its end? And why did this particular ice age wreak more havoc on life than any cold snap since? The answers to these questions are probably all out there somewhere, just waiting for us to dig them up.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Rising sea level. Scientists have determined that global sea levels have been rising since 1900 at approximately 0.04 to 0.1 inches or 1 to 2.5 millimeters per year, with a more recent study claiming a rate of 0.14 inches or 3.5 millimeters since the early 1990s. Although it doesn't sound like a considerable amount, it can have potentially large impacts by putting thousands of coastal cities and whole islands at risk of being swallowed by the ocean. 2 methods contribute to the rise in sea levels. 1, the melting of the polar ice caps and glaciers, and 2, the expansion of seawater due to global temperature rise. Predicting the amount that oceans will rise is difficult at best, with experts estimating a rise of 2.5 to 6.5 feet, or 0.8 to 2 meters by 2100, and more dire estimates of 23 feet or 7 meters, enough to submerge London.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Global warming is killing our oceans. A new study predicts that within 15 to 20 years, human-caused deoxygenation will be felt across the world's oceans. With climate change warming seawaters, oxygen levels in the world's oceans are beginning to drop. Surface water with higher temperatures absorb less oxygen. Such surface water is also more buoyant, so oxygen is less likely to make it into deeper water. The resulting conditions are dangerous to marine ecosystems, which depend on oxygen for survival. With the threat already underway, changes in the southern Indian Ocean and parts of the Pacific and Atlantic will be felt as early as 2030. Oceans in eastern Africa, Australia, and Southeast Asia, however, won't feel the impact until the next century. Worsening the effects of deoxygenation is an increase in carbon dioxide, causing oceans to be more acidic and less habitable. Researchers say carbon emissions must be reduced if we want to slow the oxygen loss, but monitoring and understanding where the oxygen levels are dipping and how it's impacting our waters is also key.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
When this magma exploded from the surface, it ripped apart tons of rocks with an ear-splitting blast. This mega explosion caused the loudest noise in recorded history. The striped pumice on Rakata proves that magma mixing was the trigger. But Krakatoa wasn't just the loudest volcano in history. It was a killer. Because Krakatoa itself was uninhabited, some of the volcano's first victims were at Ketimbang, a village on the southern coast of Sumatra. But Ketimbang is on the mainland, 20 miles from Krakatoa, and separated by the waters of the Sunda Straits. How these people fell victim to the deadly ashes was a mystery. To uncover the answers, we have to return to the scene of the crime, Rakata, and to these imposing white cliffs. They may seem part of an ancient landscape, but these 200-foot white cliffs were laid down in a matter of hours. They are what's left of a raging torrent of hot gas and rocks, a terrifying force of nature known as a pyroclastic flow.
Pyroclastic flows travel extremely quickly, so you can't outrun them. They're also extremely hot, several hundred degrees centigrade, so they will, if you're caught in the middle of one, they will incinerate you instantly.
Perhaps the most famous victims of a pyroclastic flow lie at Pompeii, the Roman settlement that was utterly destroyed during the eruption of Vesuvius in Italy in the year 79. The perfectly preserved remains of the people here are testament to the power of these fiery avalanches.
And most people die not because of 100% burns, but because they inhale the gases, which are so hot that they just destroy the air passage in the lungs instantly. And so after 2 breaths, you're dead.
The sheer size of the cliffs at Rakata have led geologists to estimate that the pyroclastic flows thrown out by Krakatoa were an amazing 2,800 feet high. But the victims of this deadly torrent were on the other side of the Sunda Straits. What happened next was truly astonishing.
Pyroclastic flows are ground hugging. In other words, they follow the ground surface as they go down, but they also have an upper part which is very rich in gas, so it's low density. Now when a pyroclastic flow hits the sea, the dense bit carries on down onto the ocean bed, but the gas-rich but still very hot bit goes hurtling across, scooting across the top of the water. There's virtually no friction between the gas and the water, so it can travel a very long distance.
Over 2,000 people at Ketimbang perished from the burning debris that could not just walk on water but run at amazing speeds of up to 200 miles per hour across 20 miles of open sea.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
The third worst day on Earth. The KT extinction.
$65 million years ago, we would have seen a world something like Africa in terms of the number of animals out there. But instead of big mammals, we had big dinosaurs. Herds of triceratops, herds of duck-billed dinosaurs, small to big predators, the largest being T-Rex.
Dinosaurs ruled the prehistoric world for almost 200 million years. Then something took out 2/3 of all living creatures, including the giant beasts. After years of searching for clues, most experts now agree that a single cataclysm doomed the dinosaurs.
The evidence for an impact of a 6-mile-wide asteroid 65 million years ago is about as good as anything gets in science.
65 million years ago, a rock the size of Mount Everest barreled down from the sky and slammed into the Yucatan Peninsula near modern Chicxulub, Mexico. The impact unleashed an unstoppable chain of destruction. First locally, then across the globe.
The KT is an asteroid-driven extinction. A big rock from space came down, clunked a few dinosaurs on the head, but the kill mechanism was really the secondary effects of this. It would have been darkening of the atmosphere, acid rain, a change in the entire biosphere.
Proponents of the single impact theory point to a convincing array of evidence, including high levels of the asteroid element iridium at the KT event's geological boundary, or death layer, and of course, the smoking gun itself, the underwater crater in modern Mexico. But is this cold case finally closed? Some scientists now argue the Yucatan asteroid had accomplices.
There seem to be various causes that can trigger these, and in some cases, several causes come together in sort of a confluence of bad circumstances to provide a particularly damaging extinction event.
Millions of years before the KT extinction, vast lava flows had been pouring out of the Deccan Traps, a series of lava beds now located in southwest India. These flood basalts once spewed out enough magma to cover 1 million square miles and belched up a toxic brew of gases that could have altered the climate around the world.
That period of eruption is pretty coincident with the extinction 65 million years ago as well. And in fact, they were going on for millions of years before the KT impact and before the extinctions. And so perhaps could be a complicating factor.
In this scenario, the dinosaurs received a double knockout blow. First, the rampant volcanism of the Deccan Traps, then the Yucatan impact. And a small group of dissenters goes even further, claiming that multiple asteroids struck Earth at roughly the same time, 65 million years ago. According to them, the Yucatan impact wasn't the largest, only the best documented.
Some people think that there may have been multiple impacts, a shower of impacts, for example. Perhaps they came from a single object that broke apart.
Supporters of this hypothesis point to a suspicious geologic feature, a 370-mile basin off the coast of India, more than 3 times larger than the Yucatan impact site. But controversy swirls around this so-called Shiva crater, named after the Hindu god of destruction, including whether it's even a crater at all.
While this feature certainly looks circular and looks crater-like, there's no other evidence that it's an actual impact structure.
For some, the dinosaur die-off debate rages on. But most scientists agree the apocalyptic event was a very fortunate day for small mammals that were no longer dinner for T-Rex.
Had it not been for the KT impact and the volcanism that was also at the time of the extinction of the dinosaurs, the mammals probably wouldn't have risen to the prominence that they did. And thank heaven for the rise of mammals, because that led to the rise of humans.
The KT extinction raises a sobering question. Could humans one day go the way of the dinosaurs? That's what viewer Tom Moore from Adrian, Michigan wanted to ask the universe. Will Earth be struck again by a KT-sized asteroid?
Well, Tom, Earth could definitely be hit by another KT-sized comet or asteroid. They're out there. The good news is we're tracking the positions of most of the big ones. So if we ever find one with Earth's name written on it, Hopefully we'll be able to deflect it before it reaches Earth.
The KT event toppled T-Rex, but it only ranks as number 3 on our countdown of worst days on Earth. Number 2 was the mother of all extinctions, the greatest die-off that life on Earth has ever suffered. It's also been one of the biggest unsolved mysteries in science until now.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other. As the edge of the sea floor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Imagine if you could gather the energy from every star within 100 million light years, from thousands of galaxies, each with billions of stars. Imagine you could take this kind of power and use it to fire the biggest superweapon in the universe. Imagine the damage you could do. It turns out, you don't need to imagine it. These exist, and they're called gamma-ray bursts. But what are these cosmic snipers? And what happens if one takes a shot at Earth? To understand gamma-ray bursts, we first have to understand gamma rays. Gamma rays are electromagnetic radiation, waves which carry energy just like visible light. Visible light is a tiny part of the electromagnetic spectrum. It's the part your eyes can see. At lower energies, there are radio waves, microwaves, and infrared. And at higher energies, ultraviolet, X-rays, and gamma rays. Gamma rays are incredibly powerful. A single gamma ray photon is more energetic than 1 million visible photons combined. Their high energy makes gamma rays a form of ionizing radiation, meaning they are energetic enough to break apart atomic bonds. This makes them dangerous to you and me. Ionizing radiation disrupts the delicate biochemical machinery that keeps us alive like a 9mm bullet through a clock. Fortunately, on Earth, the ozone layer blocks gamma rays, filtering them out before they can harm us. But if the atmosphere blocks gamma rays from space, how were gamma ray bursts, or GRBs, from space ever discovered? During the Cold War, the USA sent up spy satellites which could detect gamma rays from Soviet nuclear tests in space. They didn't see any bombs, but they did observe faint bursts coming from space, lasting only a few seconds. To date, this may be the only major scientific discovery made by spy satellites, that we know about anyway. Astronomers use telescopes that see different kinds of light to make their discoveries, and these spy satellites gave them a new pair of eyes. They were a mystery for 30 years, but eventually we discovered the source of a GRB, a galaxy 6 billion light-years away. If a GRB can be seen from such a distance, then it must be incredibly energetic, releasing more energy in a second than the Sun will in its entire 10 billion year lifetime, making GRBs the brightest events in the universe. So, where do they come from? GRBs accompany some of the most violent cataclysmic deaths in the universe and the birth of black holes. There are two types of gamma-ray burst, short and long, and each has their own source. Long GRBs last about a minute, and scientists think they are produced by supernova, when the core of a massive star collapses to become a black hole. Short GRBs last a second, and are produced when two neutron stars in a binary merge. Over millions of years, their orbits decay by emitting gravitational waves. Once they're close enough to touch, they crash and splash into each other, forming a black hole. Both supernova and neutron star mergers make the same thing: black holes surrounded by a magnetized disk of gas left over from their parent stars. In these environments, the rotation winds up the magnetic field, which funnels hot jets of particles traveling at nearly the speed of light. The gas in this funnel creates two tight jets of high-energy gamma rays, like a celestial laser gun. So unlike other cosmic explosions which spread out and fade, GRBs stay focused and can be seen from much further. Any more detail would require too much mathematics for a YouTube video. The universe is full of these cosmic snipers, firing blindly and randomly into the dark, and they're hitting us all the time. On average, we detect one per day. Fortunately, most are harmless. All the bursts we have detected so far originated outside the Milky Way, too far away to hurt us. But a nearby GRB could be disastrous. If one goes off within a few light years of us, it would totally cook the surface of the Earth, or at least the half that's facing it. But even a more distant GRB could still end life on Earth. And it wouldn't need to score a headshot to kill us. If originating from a few thousand light-years away, it would be 100 light-years wide by the time it reaches us, washing over the solar system like a tidal wave. Again, the ozone layer protects us, but it's better equipped to handle the trickle of ultraviolet from the sun. A gamma-ray burst would overwhelm it, leaving us exposed to deadly solar radiation. Ozone takes years to replenish itself by natural processes, which is more than enough time for the sun to burn the Earth sterile, or at least to kill most complex life. In fact, this may have already happened. A GRB has been suggested as one possible cause of the Ordovician extinction 450 million years ago that eradicated almost 85% of all marine species, although it's pretty much impossible to prove. Gamma-ray bursts could even be one reason we don't see life anywhere else in the universe. They might be wiping clean huge chunks of it on a regular basis. It's been suggested that because of GRBs, only 10% of all galaxies might be hospitable to life similar to us. So, are they going to kill us? Probably not. In a galaxy like ours, there may only be one GRB per millennia, and to harm us, they must be close and directed at us. But since gamma rays travel at the speed of light, we won't know one is headed our way until it arrives. So there could already be a GRB on its way to kill us all, and we won't know it until it hits us, and we're dead.
I'm not your friend anymore. You're not my friend anymore, 'cause you touched my...
Animal diseases that people can catch are called zoonoses. Many diseases affecting humans can be traced to animals or animal products. You can get a disease directly from an animal, or indirectly, through the environment. Farm animals can carry diseases. If you touch them or things they have touched, like fencing or buckets, wash your hands thoroughly. Adults should make sure children who visit farms or petting zoos wash up as well. Though they may be cute and cuddly, wild animals may carry germs, viruses, and parasites. Deer and deer mice carry ticks that cause Lyme disease. Some wild animals may carry rabies. Enjoy wildlife from a distance. Pets can also make you sick. Reptiles pose a particular risk. Turtles, snakes and iguanas can transmit salmonella bacteria to their owners. You can get rabies from an infected dog or toxoplasmosis from handling kitty litter of an infected cat. The chance that your dog or cat will make you sick is small. You can reduce the risk by practicing good hygiene, keeping pet areas clean and keeping your pet's shots up to date.
Nation Street, Palabra Limbo.